Hi, everyone. Welcome to day 4. It's day 4. It is day 4 of the AI Agents Assemble Hackathon. Very good news. We have crossed 5,000 registrations. So it's quite awesome. And the Discord is super busy. Today, we're going to talk about Oumi. I believe I pronounced that correctly.
Yep.
So Oumi is one of our title sponsors. Really big reward for them. If you're just joining, $3,000 cash, which is one of the highest rewards in the hackathon. And also some of the top performers will get interview opportunities at the company as well. We have done this many times. We did it with the Cubescape, which is a security project in CNCF landscape. People have been hired from the community into Kestra as well, who is also our sponsor. So it's just nice that the maintainers of the project can directly interact with amazing people and give them opportunities. So this is your time to build. And as I mentioned already, it's highly encouraged to try out different sponsor tools to maximize the chances of winning. And all the sponsor tools go well with each other. So what are we doing today? Oumi is a fully open source platform that streamlines your entire lifecycle of foundation models. So in this session, we're going to learn how you can build your own custom AI in just a few hours and not like weeks and months, because we only have like a week for the hackathon. We have experts joining us. We have Stefan and Manos from the Oumi community. They're going to be answering your questions live as well. And if you are watching this live and you want to ask them questions, it's an open source community. You can contribute as well. The link to the Discord can be found in the descriptions below. If you're watching it on Twitter, then I've added the links to the website and Discord and everything in the description as well. Or just go to the vMakeDevs website and you can find everything in the resources section. Like literally everything is there. So if there's one website that I will share with you that you can find all these links and resources and guides and everything, it's the vMakeDevs Hackathon website, resources section. Everything is there, including the links to Discord and everything. But very excited for today's session. Let's kick off with some intros. Stefan and Manos, you can go, and then we will get started with the presentation. Manos and
Hi,
Stefan.
everyone. Very nice to be here. Manos, CEO to me, came from Google, where I was leading efforts for Gemini. Stefan?
Hi, yeah, thanks so much, Kunal, and welcome everyone. Really glad that you're here and trying out Oumi. So my name is Stefan, and I'm the lead developer relations engineer at Oumi, so formerly from Meta and Twitter.
Amazing. By the way, just a reminder, we will be answering all the questions in the end, so it doesn't break the flow. And please send in your questions in the chat. Don't worry, I will make sure I ask the panelists here. And let me just share the screen real quick, and Manos, take it away.
Yeah, okay. So again, very excited to be here. Thanks everyone for joining. As Kunal said at the very beginning, it's time to build. And Oumi helps you do exactly that. It turbocharges you so that you can hack, you can build your own custom AI dramatically faster and easier than ever before. It's one of its kind platform that gives you all the tools that you need, from how you synthesize and you build your data, how you evaluate your models, or many different training approaches for LLMs and vLLMs, and all the tools that you need end to end. So you can build your own custom models, and for a specific use case that you target, you can even build GPT-5. And actually later today, we're going to be showing you how you can do that by tuning a small model to beat GPT-5, to match or beat GPT-5 in a very specific task. So Oumi gives you all these tools that you need so you can put your enterprise, what you're doing, on the right AI future. Because the future for AI is going to be custom open source AI. If you are an enterprise and you are just curating prompts for the GPTs, Claude, or Gemini that I was building at Google, you're going to likely end up on the wrong side of history. You're going to end up getting out innovated by some other company that is building their own custom AI that has higher quality, much lower cost and latency. So if you're an organization, that's the type of AI, that's the type of strategy you need to be on. If you're an AI engineer at an enterprise, that's the type of technologies you should be bringing into your company. And if you're a student, that's the type of skills that you should be building. But you may say, okay, if I look around and I see most companies now using this closed AI, the APIs by OpenAI, Anthropic, or again, Gemini, that my team was building at Google. But those come with a lot of issues. They offer very limited capabilities for you to customize and develop the best AI possible for your use case. Limited privacy and security, right? You have to send your data, as many say, I can't send my data to OpenAI, that's a concern. Limited transparency, auditability, right? This is a black box. And they lock you in, the solution has very high licensing costs. The mindset, though, in the industry started changing less than a year ago when DeepSeek came out, sent an earthquake through the industry. When more and more enterprises, and we were like discussing with them since then, they told us, we started realizing that now we can use open models, and the moment we customize them, especially, they can become way better than the closed models. So it doesn't make sense anymore for us to use the closed ones. So the open models, when you customize them, again, you can have a lot of benefits. You can end up with something that's much higher quality, lower cost, lower latency. It's better for privacy and security, right? You choose where you deploy them, more transparent, you don't get locked in, you're in full control, and at lower cost. So many enterprises have thought this is clearly our future. We know this is the future. This is what we want for all the benefits, but it is hard to do it. Well, it's not hard anymore. It used to be hard because that's why we founded Oumi. We founded Oumi to make AI truly open, to make it easy for an organization to succeed with AI, to democratize both the use and the harnessing of AI by organizations, but also the advancement of AI. We in Oumi helps enterprises to easily create their own custom AI models, again, dramatically faster and easier than before, so they're not stuck using GPTs, Claudes, and Geminis. Also, it empowers academia to easily do AI research so they can contribute and collectively help advance frontier AI. Oumi does it in 3 different ways. The first one is the open source that we're going to be focusing also today in the hackathon. It's end-to-end repository that gives you, again, all the tools you need from pre-training, post-training, full fine-tuning, parameters fine-tuning, RL techniques, evaluation, again, all the tools that you need to develop your own custom AI. It's already over 8,700 GitHub stars. It's being used by engineers in many of the most notable companies. Also recently won a Fast Company Next Big Things in Tech Award. Also, we have an enterprise platform that's going to be released in a couple of months that makes it even easier for enterprise to develop their own custom models. If somebody has interest, please let us know. And for some organizations that need more help, we can also help them develop the solutions. So as I mentioned earlier, the open source is what we're going to be focusing in this hackathon. So also, as I mentioned earlier, I'm Manos, CEO at Oumi. I came from Google, where I was leading and actually bootstrapped the efforts for what became Gemini. But I was convinced in them back then, and even more today, that there was a better future, a better AI future worth building, both for enterprises, science, and humanity overall. And that's why we set out to build with Oumi. So if you want to get started, please go to GitHub. The link should be in the description. You can go a long way to support Oumi with us. Also, if you have any questions, you can also ask them in the Discord. Again, all these links should be in the description channel. With that said, I'll pass it off to Stefan that will tell you more about Oumi and how you can train your own model that can match or beat the quality of GPT-5. Stefan, over to you.
Yeah, thanks so much, Manos. And so likewise, I'm really excited to be here, and I'm really excited to see what all of you folks build. It's going to be great. So I'll just reiterate. Please go to our GitHub. We'd really love if you gave us a star and checked it out. Also, we have a very active Discord, so you can scan the link there. And the Discord, really good place if you have any sort of like technical hitches during the hackathon. The best place to ask those sort of questions. So as I mentioned before, so my name is Stefan, and I'm the lead developer relations engineer at Oumi. But in a previous life, I was an applied research scientist working at Meta and Twitter. And I really love, as a developer relations engineer, I really love connecting with users. And so I love to get your feedback, hear what you're building, help you through any sort of obstacles. So please do connect with me on LinkedIn. I'd love to hear from you. So here's what I'm going to be talking about today. So firstly, a bit more about what is Oumi. So Manos has touched on the Oumi, the company, and the mission. But is Oumi, is it just like a company? Is it a product? Is it a global movement? Well, I'll tell you a bit more later on. After that, we're going to be looking at a specific case study, and the application is going to be text to SQL. So prompting a large language model to take natural language and convert that into a corresponding SQL query. And the question is, can we fine tune a small model with Oumi to match or to beat GPT-5? And we'll actually go through a Jupyter notebook there. Then to wrap it up, I want to give just like some general hackathon suggestions. So a few of you have reached out to me and asked, have you got any like specific ideas that might help me get started? And so the answer to that is yes. So I'll be talking about that at the end, giving some general guidelines, some specific ideas, and just like helping you get started to build something with Oumi. And then we'll leave some time at the end for questions, of course. So you might have questions like, what can Oumi do? Can it do this? How do I actually do that in Oumi? Or maybe like you've already started building with Oumi for the hackathon, and you got stuck. We can help out with that at the end. So what is Oumi? Well, let me tell you a bit more about open source Oumi and explain what the product is. So I like to think about it this way. So Oumi is like a higher level of abstraction, building on all of these open source ecosystem tools. For example, the Hugging Face libraries, vLLM, vEL, SkyPilot, evaluation tools like LLM-eval. And so it's a library that builds on top of these libraries to give you one higher level of abstraction. And so you could say like how in the same way that Hugging Face is one level of abstraction higher than PyTorch, Oumi is the same thing to the open source generative AI ecosystem. And so what that means is that you can do open source AI really, really easily. So you don't have to go through every time you want to do a task and code up like your inference loop or your training loop, or actually sort of call the eval libraries yourself. You can work at a much easier, high level of abstraction. So there's two ways, or actually 3 ways that you can use open source Oumi. And the first is through our command line interface. So you pip install the Python library, and then you have access to this command line interface tool. And so you run it like this. You call Oumi, and then one of a number of different verbs, the step of the pipeline that you want to complete. And then you give it a configuration file. And so this is like a YAML file, which describes at a high level what the different parameters of what you're trying to do are. So for example, if you're training, contain things like your model name, your learning rate, learning schedule, and so on. So that's one way. That's a no-code way of using Oumi. There's also a low-code option. So you can access open source Oumi via the Python API, and using some analogous classes or objects that you create after importing Oumi. You can do the same steps. So instead of Oumi train, you would create a training config object from the same configuration file, and then call the train function. So this gives you a bit more flexibility, but then on top of that, it's 100% customizable. So if you actually want to go in and replace, maybe put in like a custom training loop, you can go in and replace that component. Okay, so Oumi, open source library that has everything you need for end-to-end model development. But what does that mean more specifically? So end-to-end in the sense that it covers all steps of the model development pipeline. And so that's data synthesis, pre-training, and then post-training. So different types of fine-tuning, evaluation, and LLM-as-a-Judge is a type of evaluation, inference, and it's able to do that on pretty much like all of the open source models out there with like a recipe or configuration that is baked in or available from the GitHub repo, and also at different scales. So if you want to run it on your laptop, you can do that very easily. But then if you want to sort of scale running on AWS on a number of GPUs, with a few small changes to the configuration file, you can launch that job on the cloud. Also, as I just mentioned, you can run it anywhere, on device, cloud, on premise, and so on. And 100% customizable. So all of these different components of the pipeline, you can use the built-in abstractions as is, or built-in components. But if you want to actually take one of those and do something slightly different, then you can go in and customize them. So this is really good, for example, for researchers, or for builders who maybe like they're building something that isn't sort of like in the standard Hugging Face library yet, for example. So we're really excited to have had so much traction so far. So 8.7 thousand stars on GitHub, so go and check us out. And do join our Discord as well. We're really active over there. Okay. So Oumi, I really want to emphasize, is a community-driven project. And that means that in addition to our core team, so 20 plus people from all of these big tech companies, we've had a number of really great contributions from community members. So people like yourselves who are like hackers, builders, really passionate about open source and building cool stuff. So we would love, if you have any ideas and you want to contribute to Oumi, we would really welcome and support that. And we would sort of like help, guide you through the steps in doing that. Oumi also has strong connections with academia. So we have a number of we call them, founding scholars across a number of leading institutions. So it's everything from like Stanford, MIT, Oxford, Berkeley, etc. And another aspect of being a community-driven project is we use your feedback to guide the development. So after you've experienced Oumi, you've built something really cool, we would love to hear about it and hear what you loved about Oumi and how we can make it even better. Okay, so let's go over, so this is the main part. Let's go over to a case study of using Oumi to fine-tune a small language model to do text to SQL. So I'm going to be taking you through this notebook here. Okay, so the first step, so you could just imagine you were doing this as like maybe a project as part of a hackathon. The initial step is to ideate. So think like, what is an interesting problem that we can tackle? You may know that text to SQL is often a step of RAG pipelines. And RAG is a type of, maybe like you could think of it as like a simple type of agent. So it's very relevant to the theme of the hackathon. So after you've ideated, then you can start going through these different steps of the building your system. And part of that building the system is training the models that will make up that system. So before we can train our model, we need to get our data and to process that. So I'm going to like skip over or go very quickly through. So some of these cells are more important than others. I think the data processing maybe not so pertinent. I'll be sharing the notebook after the webinar, so you can sort of go through it, all the different parts in more detail. So, but we're starting off with the data set from Hugging Face. And, oh, okay, let me go back. Yeah, so we're starting off with the data set from Hugging Face called Spider, which contains a number of examples of natural language queries, and then the corresponding ground truth, and the like a schema fit for each of those different queries. So we just start off with a bit of pre-processing. I've got a script here, so I'll share this afterwards. We download the data from Hugging Face, And then we just does like a tiny bit of like data munging to change the format of the rows to make it compatible with Oumi out of the box. So let's actually let's just take a look at some of these samples just to get a sense of like what's going on. So here's an example of one row. So you can see that those scripts have divided the data into test, trade, and validation. And we'll take a look at one row just to understand like what is the format of the data, like what does it contain. So firstly, within each row, this field here has, so request has the actual.
Stefan, can you maybe zoom in a little bit? Sorry.
Perfect, yep.
We have close to 500 folks watching, so please keep the questions coming. We'll be answering in the end. That looks great. Thank you.
Okay, yeah. Thanks for letting me know. So taking a look at a row of the data, here is one of the prompts. So given the following database schema, write a SQL query to answer the question, and then it's got the schema, some metadata about the table, and then it has the natural language query. So what are the distinct template type descriptions for the template ever used by any document? And then the actual sort of question in the prompt is that the large language model needs to write a SQL query that answers this question and format it in this way. And in this data set, we also have the ground truth. So here's an example of the ground, and then, etc. Okay. So we've got the data, we've downloaded the data, we've done some pre-processing, where the next step, I think, is to set up our LLM as a judge for evaluation. And we're going to use some really convenient built-in features from Oumi to do that. So what I'm going to do here is define a judge that evaluates a response, but is like specialized to this natural language to SQL task. And so a judge, an LLM judge has two parts. It has the prompt, and then there's the actual model that runs the prompt. So firstly, the prompt, we will give it a natural language to SQL quality judge. Your task is to decide whether a model's SQL response fully and correctly answers a natural language question using only the provided database schema, return exactly true or false. And then I think it's a good idea when you're defining LLM-as-a-Judge to be really specific. So we really clearly define inputs, decision rule, evaluation criteria. That's really important. Schema adherence. So you can see how we've really specialized this. And I'll just skip over the rest, but you can see there's a lot of details in this judge prompt. And then, so this is now where Oumi comes in. We give it a prompt template, and that sort of like connects the data that we feed in to the judge. So we tell it that it has one field request and then another field response. And these are referred to back here in the prompt. So that's the prompt. Also the template for connecting the data. So finally, the model. We actually need to specify a model to run this. And in this case, we're going to use GPT-5 because it's typically a good idea to have a very strong base model for your judge. And is there, I think, maybe perhaps the only stronger base model than GPT-5 is Gemini 3. So, but if we wanted to use a different model, we could, if we wanted to use GPT-4o, we could do that. If we wanted to plug in a different inference provider, maybe we wanted to use Lambda or Together.ai or another one of these inference providers, then all we have to do is change engine and the model name, and then we would be using that other service. So you can see how Oumi provides a unified interface to inference and all these other steps of the pipeline. Okay, so we've defined our judge. I think it's a good idea, like when you're sort of like developing, to sort of like test each step before you move on. So I'm going to actually judge a single sample that's true and a single sample that we've taken a true answer and then we've corrupted it. We've made a small change that means that it's no longer true. So so it's compatible with the command line interface. I've taken the full data set and I've just extracted a single row and put that into its own JSON lines file. So if you're using the Python API, you wouldn't need to do this. You could just sort of extract that one row within Python. But because we're using the command line interface, the no-code option, we have to like extract this into a file. So this is one row from the validation set, and then here's the same row, but I've made a small change. So can anyone tell where the change is? So I just changed literally one of the letters, one of the references to the tables from, I think from like T1 to T2 to, so it doesn't make sense. But let's see if the judge can pick that up. Okay, so well, I've actually hard coded it here when I created that single false file. So let's test it out. So to run Oumi LLM-as-a-Judge from the command line, we use this command here. So Oumi judge dataset, and then we pass in the configuration. So this is the judge prompt and model that we defined above. And then we also pass in, so the input, that single row from the dataset. And so we've given the response is the ground truth. So it should show that it's true. And yeah, so I just run this in advance. You can see that it does judge it as true, and really importantly gives an explanation as well. So you can see here how Oumi made this standard task of LLM-as-a-Judge really, really easy. So let's try on the other sample now. So we'll run the same command, but with single false. And as we hoped, the judgment was false. And you can see here, so the explanation it gives is correct. It sees that I changed one of the numbers in this join condition. So instead of t1.template type code, I changed them so that they're both t2, which doesn't make any sense. Okay, so we've just done like a basic sort of like vibe check on our LLM-as-a-Judge, and that's looking good. So the next step before we do any training is we should calculate our baseline metrics. And so the metric is going to be this correctness from the LLM-as-a-Judge on the validation set. And the two baselines we're going to look at are, firstly, the model that we're fine-tuning before we've actually done any fine-tuning. So just the unfine-tuned Qwen 3 8B, as well as GPT-5. So to calculate this metric, first we need to get the completions from our model, and then we feed those completions into the judge. So to run the completions, we need to perform, and so the first step is to define our configuration file for inference. And you can see like we're doing this all a much higher level. You're not having to work with any of the sort of, lower level Hugging Face objects. We describe the model name, other parameters, parameters to do with the sampling process. And then we tell it what inference engine to use as well. So native means Hugging Face. You could replace that with vLLM. One of the many other online inference providers. There's a lot of different inference engines. Okay, and then so to actually run the inference, we call Oumi infer. We pass in that configuration file. We give it the data that contains the prompts, and we tell it where to save the data as well. So I had to run this on another machine, so I haven't got the cell here. But this is sort of like a step where you do need access to at least one H100 GPU, ideally 4 to 8. So we've done the inference on Qwen. We've produced we've completed the prompts. We'll do the same with GPT-5. And you can see it's very, very similar. We've just made a few small changes to the configuration file. So we've replaced model name with GPT-5. We've replaced the engine with OpenAI. And we've defined a few extra parameters here describing how the remote inference should be performed. And then we call the same command. So Oumi infer, but with this different, with this new configuration file, as well as a different output. And so GPT-5, all you need is an account for this one, so you don't need access to GPUs directly. So we run that. That produces the completions for our natural language queries. So we've got that. Before we can actually feed it into the judge, we just need to do a tiny bit of data transformation to get it from the output of the Oumi inference command to something that Oumi judge can read directly. So I just do a tiny bit of renaming the field names, both for for Qwen 3 as well as GPT-5. And then once we've done that, now we can call the judge. So the judge now has access to the prompts, the completions from the models, and then it can actually call GPT-5 with that judge and do the judgments. And for that, as above, we use Oumi judge dataset, but now this input doesn't have a single row. It contains this, I think it was 500 samples from the validation set. And it outputs it to this judgment file. So we can take that, we can read it, and then we can calculate the mean. So in this case, it's 82%. So without any fine tuning, so the LLM-as-a-Judge has judged that 82% of the prompts, the model was able to create the correct SQL query corresponding to that natural language query. So now we'll do the same thing with GPT-5. So GPT-5, we expect that this should be a much higher baseline because GPT-5, much stronger model than an 8 billion parameter open source model that hasn't been fine-tuned. So we do the same thing. We just replace the input with the completions from GPT-5. Run the same command, and I can actually do that on my system here. We get about 90% or 89.7%. So you can see that the strong model, GPT-5, it's about 7% better than just the unfine-tuned small language model. Okay, so we've calculated our baselines. Now we actually want to do our fine tuning. And so this is like a step where it's going to require like experimentation to sort of determine what works. And so maybe like the first thing you try is you sort of like fine tune directly on your training data. But then you may find that that doesn't give as good results as you want. So there's a few things you can do from there. And one of those is to fine-tuning set from your training set that's been like carefully curated to improve fine-tuning. And so I'll post the code later for this. It's not that interesting for the sake of the webinar, but let me just describe what I did here. So to curate the fine-tuning training set, I combined 50% of the prompts that Qwen3 got incorrect on the training set, because we have the ground truth, we know whether Qwen3 is correct or not. So I took those incorrect prompts, I took the response from Qwen3, and then I prompted GPT-5 to adjust it so that it was correct. So it's sort of like it's made like a sort of like a small modification to the default output of Qwen3 so that it is correct. So 50%. So maybe you can think about it like this. It's working out which of the hard examples, and then how can it sort of do like an adjustment, like a small adjustment to its existing output to give the correct answer to those hard examples. And then the other 50% were just the prompts, so just like a random sample of correct prompts under Qwen3. And so in that way, I have curated a fine-tuning train set that it turns out results in like a better fine-tuned model. Okay, so with that, but you can sort of assume that before we knew to do this, we had to try like maybe 2 or 3 other things to work out like what worked. And so that's just like part of like building generative AI apps. There's going to be some experimentation, but you can be guided by your previous experience and sort of like rules of thumb of like what you know has worked in the past. And so this particular strategy here, like sort of combining some corrected samples plus some just like default samples, that's something that I know in like the past worked for other fine-tuning applications. Okay, so let's go to the actual fine. So we write this configuration file to do the fine-tuning, and we create these different fields like model. We give it the data. We tell it what sort of trainer to use. So in this case, we're doing full fine-tuning. So supervised fine-tuning on all the weights using TRL. We'll train for 1 epoch. I'll post all this afterwards so you can have access to the parameters. So this is a step again. You do want to like have more than 1 GPU on your like the cloud system that you're using to fine tune to fine tune all of the weights of this type of model. So, but Oumi makes it very easily to take what was just like a description of a training job for 1 GPU and then to run it on multiple. So we can take this Oumi train command, and then we can preface it with Oumi distributed torch run. And so now it's going to run that training job on a number of GPUs. Okay, so you do that, wait 4 hours, I think it was between 4 to 8 hours, come back, you've got your saved model. Now we can do the inference on that fine-tuned model and feed that into the LLM-as-a-Judge. So I create an inference configuration, the only change I make is now I change the model name to this fine-tuned one. And then I run Oumi infer as before. And these steps are the same as above. So in the interest of time, because I want to leave some time for questions, I'm just going to skip down. But it turns out that we've been able to improve the results from I think it was 82%. Now we're 89.56. So we're like not, we haven't like matched GPT-5, but we've very, very closely, it's very, very close. And I think that's like really impressive because this is an 8 billion parameter model versus GPT-5. And for other tasks, you can actually like exceed GPT-5. So I think that's sort of like a really powerful example, which shows that you can do a lot with very small models, provided that they're fine-tuned for specific tasks. So 2 further steps, I'll leave these as like, exercises. You may want to like quantize the model. For example, if you want to run it on your MacBook, you could use MLX LM library to quantize it. And then you can run that on Apple hardware really quickly. And then for the purpose of the hackathon, I think it's always good to like give a good visual demonstration of what you've built. So you could, for example, incorporate this into a Gradio app that implemented a RAG pipeline. And then it would use this text to SQL to access external memory from a relational database. So that's like an example of like how you could actually use this fine-tuned model in like an agent pipeline. So hopefully, hopefully you enjoyed that, learned something, and gave a sense of like how easy it is to perform all of these pipeline steps. So most of those steps we were doing in like a no-code or a low-code way. So summing up, let me give you some general guidelines for the hackathon. So I think there's different options of what you could actually do. So you could fine-tune a model that could be a subcomponent of an agent. And so that's what we did in this example here. But some alternatives, you could work on better evals for agents with Oumi. You could work on specific synthesized agent data. Or you could do contributions for building agents. So fine-tuning a model is just one example of what you could build with Oumi for the hackathon. But whatever you build, I think it's important, given like the time constraints, is to choose like a really well-defined task with a narrow scope. So for example, another one might be text to graph query language. So that's something that is very well-defined, very narrow scope, something that you could realistically have a really interesting application built in the next 3 to 4 days. Also, it's really helpful to make use of the Oumi notebooks. So in the GitHub repo, we have a number of notebooks covering all sorts of topics, how to do everything from if you want to do reinforcement learning, or if you want to do other types of evaluations. We've got an example in that folder of the GitHub repo. So you don't have to do reinforcement learning if you're fine-tuning, but I would love to see it as a judge. I think something that we're very excited about at the moment, and it'd be really cool to have more examples of things built with reinforcement learning. So here are some references, and with some of these links will be in the description below. We'll give you access to the slides afterwards, so you can click on these links. So finally, please do visit our GitHub, give us a star, and we would love to connect with you on LinkedIn. And so with that, I will open it up to questions.
Thanks for the presentation, Stefan. I believe we have 13 minutes. We do have some questions. Do we just use the free tier, the open source version for the hackathon, or do we need to pay?
Yeah, so Oumi is so open source Oumi doesn't require like any sort of credits or API access. I think you can go, so in terms of like having inference and training resources, I think you can go a long way with the free tier of Google Colab. But maybe like if you're doing some larger fine tuning like we were here, you may need access to like some resources on AWS or like Lambda or like another GPU provider.
Cool. There's a question about, can you share how it's different from Unsloth?
Yeah, sure. So if you recall, I had a slide where I showed how Oumi builds on top of the open source generative AI tooling ecosystem. And so Unsloth would be within that box. So I believe we have like an integration with Unsloth. It is a tool that we build on top of and give you access to that, but it's at like a higher level of abstraction. So you can just define that YAML configuration and then call the command line command, or just like a single Python function.
Cool.
And maybe
Does
also,
it work in?
I was going to say, very quickly to add to this, is Oumi isn't just for training, but it's for all the other steps, as Stefan mentioned, that you have to take when you develop your own custom AI model, which curating the right data, synthesizing it, evaluations, all the steps.
Yeah, and totally. And we have a really sophisticated data synthesis feature set. So you can define sort of, quite complex templates to create synthesized data from, multiple models and data sets. So check it out. So can Oumi work in Python 3.13? Yes, it's the answer to that. So Oumi works in most versions, or all versions of Python. I think, I'm trying to remember what's like the lowest version we support, but it would definitely be lower than 3.13. How much data we actually need? Okay, yeah. So the thing about fine tuning is you don't need very much data at all. So you can get really good results with, depending on the task, 100, 1,000. You might find that the results going from 1,000 to 10,000. And I think this is especially true when you're doing like a parameter efficient fine tuning as well via LoRa. So I think it's more important to think about what is, or how do you curate your fine tuning data set rather than like how much data do we have.
So another one on the screen.
So Oumi has a really sophisticated synthetic data like feature set, and you can create like some quite complex like templates. I would encourage you to like check out the docs. I'm sure you'll be able to do what you have in mind with these features there.
Yep, Anuj is asking, we're building an accident reconstruction tool. Very cool. I'm looking forward to seeing that. We want to use Oumi for vLLM analysis of collision frames. Quen2 is consuming 18 gigabytes of RAM. What's the recommended way to quantize low memory?
Yeah, sure. So that would just be like a change in the configuration file. So if you want to sort of do like a 4-bit quantization with the bits and bytes and so on from the Hugging Face libraries, you would just make like a few changes to your configuration, and then you would go from the 16-bit to the 4-bit.
He's saying that they try to use bits and bytes config.
This would be a great question for the Discord.
For Discord, yes.
Yeah.
Anuj, join the Oumi Discord channel, and you can't send error logs here. Join the channel and just paste it there in the public channel. What's the best way to serve a fine-tuned model as a microservice that other apps like a web collector can call?
Yeah, sure. So I think for the purpose of a hackathon, I think if it's something that runs locally, then I think it's sort of like fine for a demo to just sort of like show it being called via a local server. I guess like my advice would be like maybe focus more on like the problem you're solving and the like the solution rather than like is it being served. It's like all of the pipeline sort of production grade.
Yeah. Can I monitor model performance in production with Prometheus or Grafana?
Okay, so Oumi is more for like the model development stages of the pipeline, not so much for the productionization. So you use Oumi, the end result is you have like a model artifact, and then you can put that into your production tools that connect with all of those like real-time analytics.
Yeah, and as you know, we have a lot of people signed up, so a lot of them are beginners. So someone is asking for a very beginner project, how can I get up and running with Oumi?
Yeah, that's a great question. So I think this is where the Oumi notebooks are really great. And so each of those is like a really simple self-contained example. Shows you how to do something really interesting. So for example, oh, thanks. Thanks, Glenn.
If you want to work at the company, yeah, directly talk to them on Discord and contribute. It's an open source project. So you can, yeah.
So, but to answer the previous, finish answering the previous question. So for example, you could look at the reinforcement learning example, which shows like a very sort of simple example, but I think it's interesting. It's like how many, counting the number of letters in a word. And so you could imagine sort of like taking that and then sort of like with some small extensions, you could make it into something really cool or interesting.
Okay, cool. So we have a few more minutes left. So it's another one on the screen. If we tune a small model and it becomes overfit quickly, what does Oumi give to detect that early?
Yeah, sure. Yeah. So Oumi integrates with TensorBoard as well as weights and biases. So when you're fine tuning, you should also be sort of like following the metrics as the learning proceeds. And so you should be keeping an eye on your test set and using that as a way to sort of keep an eye on overfit. It's also a good idea to keep a copy of snapshots during learning. So if overfitting happened, you can sort of after the fact do early stopping and just take one of those earlier snapshots. But yeah, I always monitor the real-time metrics during training.
Cool.
So does Oumi export models and formats that run directly on vLLM or TTI? So yeah, good question. We definitely definitely export to like a standard like Hugging Face format, and I think so. In terms of sort of like converting between all these different formats for different libraries, I think that's something like that would potentially make like a really good contribution to Oumi. How does Oumi prevent catastrophic forgetting? So yeah, great question. So I think this sort of like goes to more the details of how you do fine tuning. So Oumi gives you a lot of flexibility. You're controlling like the type of fine tuning, all of these hyperparameters, and I think like the devil is in the detail. So you might find that you're overfitting. You would just sort of like use some sort of like standard deep learning like rules of thumb. So maybe like it means that you need to do early. So maybe like you might need to add some sort of regularization, whether that's like early stopping or a modification to the training loss. But all of that you can control just like through the YAML file.
Cool. Last question, and for others who are asking questions, please join the Discord and ask your questions there.
So yeah, great question. Can we replace a smaller rule-based judge, or must we use a big LLM only? Okay, so LLM-as-a-Judge it will use a large language model or a language model as the judge. You don't have to use GPT-5. You can replace the inference engine to run inference locally on any open source model that you can download locally. You could also use one of the inference engines that uses an inference provider that's not OpenAI. But in terms of like, if you have a judge with custom logic or rule-based, I think that sort of makes it not, yeah, so that might sort of be like outside the scope of LLM-as-a-Judge. So I'm not sure like whether you mean like you just have like discrete rules, or whether you have like LLMs, you run the LLM and then you run some logic after that. But you have access to all of the output. So within Python, you can take that JSON lines file and then do some additional custom logic and then put it through Oumi a second time if need be.
Cool. Well, thanks for joining, folks. This was great. A lot of nice questions. Very nice to see. Very excited to see what you all build. And we have a lot of time left. I know people are going to be hacking over the weekend mainly. But it's nice to get that head start. All the links can be found in the description. Join the Oumi Discord, check the website. Everything can be found there. And yeah, we'll see you in the next one. I think the next stream is with Vercel starting in 2 minutes. So they're also our sponsors. So you can learn how to deploy your projects. Check it out. Thank you, everyone. Really
Thanks, everyone.
Thank you.
Thanks, everyone. Okay, bye.